Hi everyone, welcome back in lecture number 6 of our course CNC Machining Programming. And in today's lecture, we will learn how to write a CNC program for facing operation by using linear command G01. We had already covered this G01 command in our lecture number 4 for turning operation, but today we will learn the same command for facing operation. As we already know that G01 is a G code or a preparatory function which removes the material from the workpiece in a straight line. Now, one question may arises here that what is the difference between turning and facing? So let me explain you the difference between both of them with the help of this figure. So this figure shows the turning operation, and turning operation means when we reduce the diameter of the workpiece, that operation is called as turning operation. And this figure shows the facing operation, which means when we reduce the length of the workpiece, that operation is called as facing operation. So here, this is a cylindrical workpiece, and let us say the diameter of this cylindrical workpiece is D1. D1 is the outside diameter of the workpiece. Now we are removing the material from the workpiece and reducing this D1 diameter to D2 diameter up to a certain length, capital L, let us say. So this operation is simply called as our turning operation. On the other hand, for facing operation, let us say if total length of this workpiece is L and we are reducing this depth from the total length, so this will be called as our facing operation. So now here, new length will become the length, total length, original length minus depth, which we are removing from the workpiece. So this operation is called as our facing operation. Here you can see the feed direction with respect to turning operation, and this is the feed direction with respect to facing operation. Now let me explain you the difference between turning and facing with respect to feed direction. And for that, let me draw a spindle over here. Let us say this is our spindle. And here also. And this is the spindle axis or axis of spindle. Similarly here, this is the axis of the spindle. So when the feeder direction is parallel to the axis of the spindle, that operation is called as our turning operation. And when the feeder direction is perpendicular to the axis of the spindle, that operation is called as our facing operation. So I hope now it will be clear to you that what is turning and facing with respect to feed direction. After this, let us try to understand the difference between turning and facing with respect to flat bed and inclined bed. The examples of a flat bed are conventional lathe machines, and example of inclined bed is modern CNC machine. So how we will do the turning and facing for flat bed and inclined bed, let me explain you that. So for turning operation, let us say initially our cutting tool will be at this location above from the workpiece. So in a flat bed, our cutting tool will approach from this side. This is the location of the cutting tool, which you might know. And we will approach, let us say, at this particular point from this position. This is point number 1, let us say. So this is our point number 1. Now we are taking some depth of cut in order to remove this much material from this cylindrical workpiece. Let us say we are reaching point number 2 with the rapid traverse. So from point number 1 to 2, we are reaching with rapid traverse, because here you can see there is no contact of the cutting tool with the workpiece. So this is our point number 1 and point number 2. Rapid traverse. This figure I'm showing you for better understanding, okay? The same example here I'm showing here also. Now from point number 2 to 3, let us say this is point number 3. Now we are moving with linear interpolation, that is G01 code, because we are removing the material. So we are giving feed here, and the direction of feed is this one. So this is the direction of feed, and we are reaching point 3. From 2 to 3, we are moving with linear interpolation code G01. Now here you can clearly see that there is a contact of the cutting tool with the workpiece. So in order to reach from this point number 3 to, let us say, point number 4, we will move with the linear interpolation code again, G01. So we are here right now. The cutting tool will be at this particular point. Now we will move at point number 1 back. We will retract the tool from point number 4 to 1 with G00 code, because here there is no contact of the cutting tool. You can clearly see in this picture. So from 4 to 1, now we are retracting the tool at point number 1 with rapid traverse. So this will be the direction of motion of the cutting tool in case of a flat bed for turning operation. And if you analyze this, this will be our counterclockwise direction. So let me write here, counterclockwise direction. Now let me explain you the turning operation for inclined bed. So in inclined bed, as I have mentioned, that for modern CNC machines, we have an inclined bed or slant bed. Here, the cutting tool will approach the workpiece from this side. So let us say this is the point number 1. So cutting tool is approaching from a certain location to this point number 1. And let us say our cutting tool is here. And we are reaching at a point, let us say this is point number 1. I hope you are getting it. Now we will move the cutting tool at this location from point number 1 to 2 with a rapid traverse again. So this is the location of point number 2, because there is no contact of the cutting tool here with the workpiece. So now we will remove this much material from the workpiece, and cutting tool will be at this location now. Okay. So in order to reach now here from point 2 to 3, we will remove the material from the workpiece with linear interpolation code. Then we will go from 3 number point to 4 number point. Let us say here is point number 4 with the linear interpolation again, because there is a contact of the cutting tool with the workpiece. So we are moving with linear interpolation code again here. And we are retracting the tool now from this location to this location with a rapid traverse, because there is no contact of the cutting tool here with the workpiece. So we can move with a rapid traverse here, G00. So this is point number 3, this is point number 4, this is 1. Now, if you analyze this, so the direction of motion of cutting tool, the tool path will be in which direction? This is our clockwise direction. So here we can conclude that in case of a flat bed, the direction of motion of cutting tool is in counterclockwise direction for flat bed, and for inclined bed, the direction of motion of cutting tool will be in clockwise direction. So I hope now turning operation will be clear to you. Now let me explain you the facing operation for flat bed. So as we already know that in case of a flat bed, our cutting tool will approach from this side. Okay. So let us say this is point number 1. So we are moving from this location to point number 1. So here, let us say this is our point number 1 in order to understand the phenomena. Okay, sorry. Now we are moving from point number 1 to, let us say, this point with a rapid traverse, because there is no contact of the cutting tool here. Now we are removing the material from the workpiece, this much depth, let us say. So in order to remove the material and moving the tool from point number 2 to 3, we are moving with the linear interpolation code G01. Okay. So since the tool is in contact with the workpiece at this particular point, so now we are going back. Let us say at point number 4, this is point number 3 with G01 code, because here tool is in contact with the workpiece at point number 3. So that's why we are using G01 code. Now from 4 to 1, here we will move the cutting tool with rapid traverse, because there is no contact here in between workpiece and cutting tool. So we will move with rapid traverse. So this is the facing operation in case of flat bed, and the direction of motion of cutting tool here is in clockwise direction. You can see, okay, clockwise direction. Now let me explain the facing operation for inclined bed, just like in our modern CNC machines. So we know this is our cutting tool. So cutting tool is this. So cutting tool is reaching at point number 1. Let us say this is our point number 1 here. We are going here now at point number 2 with the rapid traverse. I hope you are getting it. Now, in order to remove the material, we will take linear interpolation code. We will remove the material. Okay, and we will reach here with G01 code. Then we will come back at this point. Okay, again with the linear interpolation, because the tool is in contact with the workpiece at point number 3. Then we will move the cutting tool from this point to 1 number point. I hope you're getting it with rapid traverse. So the direction of motion of cutting tool here is in counterclockwise direction. Now this is the facing operation. So we can conclude from here that for flat bed, the direction of motion of cutting tool is in clockwise direction in facing operation, and for inclined bed, the direction of motion is in counterclockwise direction. So let me write here the nomenclature which I'm using here. So I'm using here CW, which is a clockwise notation, and CCW is a counterclockwise. And L is the new length. Okay. Okay, this is L is the old length. This is the depth. So I hope now the difference between turning and facing is clear to you, that what is the difference between turning and facing. Now let us move ahead and try to write our third program in this lecture series for facing operation by using linear command G01. So this figure shows the part drawing of a cylindrical workpiece where the outside diameter is given as 25 mm, the total length of the workpiece is 70 mm, and this is the depth 2 mm. So we will remove 2 mm from this 70 mm length. Now let us move ahead. This is the starting of our program from here to here, and we already know that we are writing this program for Fanuc controller, and in Fanuc controller our program always starts with letter O. This is our letter O, followed by 4 digits. So these are our 4 digits. I had already explained this in our lecture number 4 when we were doing the programming for turning operation by using linear command G01. So those who are watching directly this video lecture, I recommend them to watch my previous video lecture, that is lecture number 4. The link is already given on the top of the screen. You can press the I button and access the video lecture number 4. So O1003 is a program name. After that, we have G21, G99. These are initial settings. G21 means input in mm, because the dimensions are shown here in mm. That's why I'm taking G21. Then we have G99, which is a G code for feed in mm per revolution. So these are our initial settings. Then we have G28, U0W0, which means we are keeping the cutting tool at its home position. So this is the code for home position. Then we have M06, which is a machining code for tool change. T is a tool function. So after T, the first 2 digits represents the tool number, and the remaining 2 digits represents the tool length offset. Then we have M03, which is a machining code once again for spindle rotation in clockwise direction. S is the spindle function, and 1200 is the RPM. So the meaning of this block is that we are rotating the spindle in a clockwise direction with 1200 RPM. Then we have G00 X50 Z-15, which means now we are moving the cutting tool from its home position at this location. This is the entry point X50 Z-15. So this is the entry point. So kindly rectify this. It will be 26, X26. Okay. Now let me explain you that where this location will be X26 and Z5. So this figure shows the analyzed view or the scaled view of this particular portion. And this is the cylindrical workpiece with outside diameter as 25 mm, as we know. So 26 will be above from the 25. So let me draw the 26 line for you here. Let me extend this line for you. And Z5, where will be Z5? So in order to understand Z5, let me draw the work coordinate system for you. So we know at the center of this workpiece, this is the center of the workpiece. This will be our positive Z. This will be our positive X. And at this center, our X and Z are 0. X is 0 and Z is 0 at this particular center. On this will be our negative X, or this will be our negative Z. So if we are moving our cutting tool towards the spindle from this point, this will be our negative Z movement. So we already know that this will be our spindle here. This will be our spindle. Okay, this is the axis of the spindle. So in order to locate this Z5, we know here Z is 0. Now Z1 will be here, let us say 2, 3, 4, and 5. This is Z5. So initially our cutting tool will be at its home position. So let me draw the home position for you. So this is the home position of the cutting tool. Which is called as machine coordinate system with its coordinates U0, W0, U for X and W for Z. So from this location, now we are moving the cutting tool at this location. I hope you're getting it with the rapid traverse code G00. And this point is X26 and Z5. I hope this line or this block is clear to you now. After this, we have G00Z minus 0.5, which means now we are giving first depth of cut with 0.5 mm. So let us say now this length is 1 mm. In order to understand the Z minus 5 location, let us say this is 1 mm distance. So this will be our 0.5 and this will be our 0.5. And minus will be from this point, if we move towards the spindle, it will be our negative Z moment. So minus Z minus 0.5 will be at this particular location. I hope you're getting it. So we are moving the cutting tool from this location. Let us, this is location number 1, location number 2 with the rapid traverse. Okay, with the rapid traverse. After this, now we are moving the cutting tool with linear interpolation G01 code X-1 and feed is in mm per revolution F0.08 because we are using code G99 here. That's why we are taking F0.08. But in case of feed in mm per minute, we will use G98 code here and F80. So kindly note this. So the meaning of this line is that we are moving the tool towards spindle center line. So let me draw the spindle center line here. This is spindle center line. So here also. So this is a spindle center line. Now, here we know X will be 0. So minus 1. X minus 1 will be below the center line. Let us say this is X minus 1. So this will be the location of this cutting tool now. And we are moving from point number 2 to point number 3, let us say, with G01 code. Okay. After that, we have G01 Z5. We are retracting the tool in Z axis. So since the cutting tool is in contact with the workpiece, okay, so we will move back with the linear interpolation and we will reach at location Z5. So if I extend Z5 line, so this will be the location of our cutting tool X-1 and Z5. I hope you're getting it. After this, now we are retracting the tool at position X26. Okay, this will be X26. Kindly rectify it. G00. After this, the program will become very simple for us if you have understood till now. So now we are moving the cutting tool now at Z-1. It means now we are taking second depth of cut. So now initially here, right now, currently the cutting tool is at X26 Z5 according to this line. Now we are moving the cutting tool from this location to this location. Now if I extend again this line, so this will be our -1. So let us say this is point number 2 prime. Okay. After this, we are moving again the tool towards the spindle center line at location X-1 with feed 0.08 mm per revolution. So we are moving the cutting tool from this location to, let us say, this location. This is location 3 prime. Okay. Then we are retracting the tool in Z-axis at Z5 location. So we are retracting the tool, and tool is reaching here at this point. Then we are moving the tool with rapid traverse at location X26. So this will be the location now. Here is tool right now. So just rectify 33 with 26. So I hope till now it will be very much clear to you that how we are removing the material, and the location is right now at X26 and Z5. Okay, let us move ahead. So this diagram shows that till now we have removed this much material. Okay, we have removed this much material. The total length which we will remove is 2 mm, and 1 mm we have already removed. And the tool is right now at X26 and Z5. So let me just show you the X26 line. We know the diameter of this workpiece is 25 mm. And if we draw a 26 line, Z is 1, 2, 3, 4, 5 here. So this is the location of X26 and Z5. So now the tool is here up to the previous line of information that we had. Now we are moving the tool with rapid traverse at location Z -1.5. So from here now we are reaching at this point, because this is 1 and this is 0.5 again. So -1.5 is this location with the rapid traverse. Okay, because the tool is not in contact with the workpiece right now, so we can move with rapid traverse. So this is the third depth of cut. And now we are moving the tool towards spindle line at X-1 once again. So this is the spindle center line. Okay, so this is X-1, let us say. And after this, we are retracting the tool at Z5 location. So from here, if we extend this line of Z5, so this is the location of the cutting tool as per this line of information. Then we are retracting the tool at X26 location, just like previous. Okay, kindly rectify it. Then we have the last depth of cut, that is we are moving at Z-2 with rapid traverse. So from this location now we are reaching here with rapid traverse once again. Okay, and we are moving the tool towards the spindle center line again at this location, let us say Z-1. Okay, then we are retracting the tool in Z axis back with the linear interpolation code. Okay, with the linear interpolation code. Then after this, we are retracting the tool at X26 location with the rapid traverse, and the tool is here right now. So till now, we have removed 2 mm material for which we were writing our program. So we have got our desired profile. So after this, now we will move the cutting tool at its home position. So from where we were calling our cutting tool, we are keeping the cutting tool back at its home position. Okay. So after this line says that we are going back, or the tool is going back to its home position. So this is the ending of the program, as we already know. After getting the desired profile, we are going back to its home position. So from here to here, this is our ending of the program. After this, we have M05, which is the M code for spindle stop, M30 for program stops and rewind. So I hope now this program is clear to you. For better understanding, let us run the same program in our CNC simulator. So this is our simulator, CNC train simulation system. And you can see on the left-hand side, the program is already written, which I was discussing with you. Now let us run this program and try to learn that how the material is getting removed from the workpiece. So let us run the program in auto mode. Now the tool is coming from its home position and taking its first depth of cut. Now second depth of cut. This is the third depth of cut and the final depth of cut. After that, now tool is going back to its home position. So I hope now this video lecture is clear to you that how to write a CNC program for facing operation by using linear command, that is G01. But still, if you face any difficulty in this video lecture, then you can comment me on the comment box of this video lecture, or you can email me on my email ID, which is written over here. And thank you once again for being with me in this video lecture. Thank you.